This lesson is going to look at literal equations, or equations with more than one variable. So this has the definition of function form, which we'll come back to later, but it does say a function form is an equation written so that one of its variables is isolated. So example, y equals x plus 1, because the y is isolated, so one of the variables is by itself or isolated. So what you might see is you might see a formula or a literal equation, a equals L times W, or area equals length times width. The question will ask you to solve it for W, or width. So that means I want to get the W by itself. So in order to do that, I have to get rid of everything that is on the same side as the W. So if I have my line again, the same side of the W is the L. So the L is being multiplied by the W. So to get rid of times L, I have to do the opposite, which is division. So I want to divide both sides by L. I don't know on the left-hand side what A is, nor do I know what L is. So I can only leave my equation as A divided by L. I do not know what either of those numbers are. Then I have my equal sign, and then here L divided by L cancel each other out, so I'm left with W. So to solve that equation for W, I'm left with W equals L, or A divided by L. So this one is a little bit more complex. This is the area formula for a trapezoid, if you recall. So the formula is area equals 1/2 times base 1 or B1 plus base 2 or B2 times h, the height. So I want to start solving this for h. So that means I want to take both sides of my equation and I want to start isolating the h. So I'm going to get rid of the 1/2 first. The 1/2 is being multiplied by all of this stuff on the right, so I want to divide both sides of my equation by 1/2. Okay, the two 1/2s on the right hand side cancel each other out, so I'm left with, in parentheses, base 1 plus base 2 times h. Now over here on the left hand side, you don't want to leave that as a division problem. Even though you don't know what a is, you don't want to leave it like that, because you can't have a fraction in the denominator of a fraction. So what the problem you really have there is really a divided by 1/2. Now remember with the rules with division of fractions. First of all, both numbers, if they're going to divide a fraction, has to be a fraction. So to make a fraction, I could make it a fraction by putting it over 1. So I have a divided by 1, or a over 1 divided by 1/2. The rule for dividing fractions is keep, change, flip. So I would keep a over 1, I would change division to multiplication, and then I would flip over 1/2 to make it 2 over 1. Then when you multiply a fraction, you multiply straight across. So a times 2 is 2a, and then 1 times 1 is 1. And anything over 1 can always be simplified to a whole number, so it's just 2a. So on the left-hand side of my equation, I'm left with 2a. Then to get rid of the other piece, to get h by itself, I have to get rid of base 1 plus base 2. That quantity is in parentheses, so that quantity is being multiplied by the height. So again, to get rid of it, I want to divide both sides by base 1 plus base 2. Okay, I don't know what any of that is, so all of this has to stay the same. So it's 2a over base 1 plus base 2. These base 1 plus base 2's cancel out, and I'm left with h, which is the variable that we wanted to isolate or to solve that equation for. I'm looking at this time the same equation, but I'm looking at solving it for one of the bases. So I want to start by getting rid of all the stuff that is not base 1. So first thing I can get rid of is the 1/2. Just like before, I can divide both sides of my equation by 1/2. As I explained on the previous slide, a divided by 1/2 turns into 2a. I have my equal sign. The 1/2s cancel each other out, and then I have base 1 plus base 2 in parentheses times the height. Okay? Now, the next term in there is base 1, but base 1 is grouped together with base 2 in parentheses, so I can't do anything with that yet because I cannot just take a number out of a parenthesis. So I have to get rid of the h. The h is multiplied by base 1 plus base 2, so I'm going to do the opposite of multiply, which is divide. So I'm going to divide both sides by h. On this left-hand side, I don't know what a or h are, so I cannot divide both sides there, so I have to leave it as the division problem 2a divided by h. Then I have my equal sign, and then on this side, the two h's cancel out. Now, I don't necessarily need the parentheses any longer because the only thing I have on the right-hand side is base 1 plus base 2. So I can just rewrite it without the parentheses. So now I can solve this by getting rid of base 2 because it's no longer connected to base 1 in parentheses. So it says plus base 2, so I want to get rid of it by subtracting base 2 from both sides. Again, I do not know what any of those variables are on the left-hand side, so I have to leave it as 2a over h minus base 2 is equal to base 1, because the two base 2's over here cancel each other out, and now base 1 is isolated. I mentioned before that we would be coming back to function form. So you have an equation 3x or 3y minus 6x equals 12, and we want to write that in function form. And it says so that y is a function of x. So we want this to be y equals something. So basically it's the same kind of literal equation as we had before, except we want to solve this time for y. So if I have the equation 3y minus 6x equals 12. Again, I have my two sides of my equation, and I want to isolate the y. So I have to get rid of what is there on the same side with it. So the furthest thing from it on the same side is the minus 6x. So the opposite of minus 6x is plus 6x. So I want to add 6x to both sides. Minus 6x plus 6x gives me 0, so they cancel out. I'm left with 3y is equal to, and then over here I have 12 plus 6x. Those are not like terms, so I cannot combine them. When you do algebra, the coefficient or the number with the variable comes before a constant term. So we have on this right-hand side 6x plus 12. Now I can start isolating the 3 again, or the y again. So the opposite of times 3 is dividing by 3. So I'm going to divide both things by 3. These two 3's cancel each other out. I'm left with y is equal to, and then now I have to take both pieces, the 6x and the 12, and divide them by 3. So I have 6x divided by 3. 6 divided by 3 is 2, so that's 2x. I still have my plus sign, and then I have my 12, and that has to also be divided by 3. So 12 divided by 3 is 4. So my final solution in the y as a function of x is y equals 2x plus 4. Sometimes you might see that taken a step further, where it says, okay, so now you have y as a function of x, or you solved for y is isolated by itself. You then have to use those results to find when x is 1 and x is 0. So that means I can then take my equation that I just came up with, y equals 2x plus 4, and substitute in the values of x to come out with the values of y. So I would have y equals 2 times 0 plus 4, and y equals 2 times 1 plus 4. In both of these equations, we have multiplication and addition. The order of operations says that multiplication comes first, so I want to multiply. So on the one on the left, I have 2 times 0, which is 0 plus 4. And over on the right, I have y equals 2 times 1, that's 2, plus 4. The only thing left I can do then is to add, so this time y is equal to 4, and over here, y is equal to 6.